And welcome viewers to the Daily Space Weather. The most enduring feature here at the Smash News Network, least busted name in news. And we're looking at the sun in some wavelengths we don't always look at here. This is 1600 angstroms ionized carbon. And there's not a lot to see here until we see solar activity, which has ramped up massively since yesterday. In terms of the radio flux, in terms of the sunspot number, the flaring. So here's 1700 angstroms, and you can see a line of like 5 sunspot groups here. And they are all beta class sunspots. And like 3 or 4 of them are beta gamma class. So it's quite significant uptick in activity here. Coronal hole activity as well. We've also got a coronal hole wind stream striking. We'll get to all of that. This is a composite. This is 1600 and 1700 angstroms from the SDO. And here's the colorized magnetogram, and you can see this sunspot here getting more complex, this one gaining ombre. So yeah, it's, like I said, a big-time uptick in solar activity there. There were some umbra associated with this little active region up here as well. We'll show you a high-res image of that toward the end of the video. Here are some more close-ups in varying wavelengths. Spectacular imagery here in 171 angstroms. How about some more ionized iron spectra? Here's 131 angstroms. And there was a nearly M-class flare in there just recently, actually. And we'll show you the flaring profile as well. 94 angstroms and 131 take 10 images per minute instead of only 2. Which makes them specifically formulated to study solar flares. So the radio flux has come up to 89 today. It was only 81 yesterday. Now up to 89. You can see the sunspot number rapidly rising. This is going to be at like 70 or 80 today. After the rest of these sunspots get named, we just see a string rising in the southeast. We don't have any geomagnetic storms or anything like that forecasted, just a brief period of geomagnetic unrest, which is actually just starting to strike now. Actually, they've moved that back a little bit. There's the refresh. You can see late in the day today, around 2100, geomagnetic unrest expected, although we do have the high-speed coronal hole wind component here already. Let's take a look at global seismicity. Having seen an uptick in the past couple of days, there was a 4.0 magnitude in Kansas. By the way, that was just a couple of hours ago here. And let's just run up the list. If we miss anything, let us know in the comments. We consider these videos a collaborative effort. More earthquakes off the coast of Oregon as well. Nothing into a 6 magnitude range. Philippines saw 5.0. Greece had a 4.5. One South American quake there at depth, 232 kilometers estimated depth there. Also a 5.1 at Fiji at nearly 500 kilometers depth. That would be like a 6 magnitude quake if it happened at the surface. And continuing on to volcanoes, some additional activity here at Kilauea. So there's a thermal image of Kilauea. That's the Halema-Uma'u lava lake. Also Mount Etna exploding. We'll get to Kilauea in a minute. Etna producing a flight level 100. It's a 10,000 foot plume of volcanic ash. La Palma. No word on the ash plume size at La Palma as it continues to erupt. Suwanosejima is exploding. That's an uptick at Suwanosejima, located in the Ryukyu Islands. It's producing a 9,000 foot plume of volcanic ash. At Kilauea, inflationary tilt was present for most of yesterday, with the onset of brief deflationary tilt just before midnight, reported Hawaiian Volcano Observatory. The lava is coming back into the Halema-Uma'u crater, which we showed you thermal imagery of. Popocatépetl, decreased volcanic activity, but still exploding, producing a flight level 210, 21,000 foot plume of volcanic ash from Popocatépetl. Fuego exploding in Guatemala, 15,000-foot ash plume from Fuego. Nevado del Ruiz, 24,000-foot ash plume over Colombia as Nevado del Ruiz explodes. Sangay exploding, 20,000-foot ash plume over Ecuador. Revenador in that same country, flight level 150, it's a 15,000-foot ash plume. Sabancaya, also continuous ash emissions. And pick up your gifts ASAP. You're running out of time to get gifts from our merch shop to your favorite people. So you can check out the links at smashamash.com as well as underneath this video. The designs are in order of best selling. Also, don't forget to become a member of the Smash team if you'd like all kinds of additional insight not present in these videos. So welcome to the Neo Renaissance. Hit the homepage, smashamash.com, check our links, support the channel, and we thank all of you who have and continue to support the channel. And congratulations on realizing the videos exist. Next, some magnetic data. We just saw a divergence here in the GOES 16 and 17 readings, as well as some adjustment of their orbits represented in these arc jet moments. When their thrusters produce plasma that could affect the readings, don't worry folks, NASA's not hiding data. That's a 3-day chart from the GOES magnetometers. And here's the top view ecliptic plane field plot. I think there's a North Pole current sheet coming. It's probably going to appear on tomorrow's imagery. So don't be surprised to see a North Pole current sheet somewhere around here. Out by stereo A, rapidly approaching Earth. Earth currently in a South Pole current sheet shown there in red. And here's the line of sight view. It also shows you the series of sunspots rising in the southeast. That sudden uptick in solar activity accompanied by the onset of a coronal hole wind stream. Here's the coronal hole line of sight plot. And you can see these South Pole oriented coronal holes now reaching trans-equatorial status. Those are the most geo-effective type of coronal holes, folks. And we've got one having provided a high-speed wind that's actually striking the Earth's magnetic moment at the moment. So here you can see these coronal holes, and we've been forecasting for a couple of months here this uptick. And there you can see the uptick in both coronal holes and sunspots at the same time. The 193 angstroms view, great at showing coronal holes. Likelihood of major flares is definitely there. We've got 1, 2, at least 3 beta gamma class sunspot groups. 2905 not so complex. A possible another one forming up here in the northern hemisphere. And that's what happens to create a solar flare warning. Likelihood of major flares way higher than it was yesterday. And here you can see the flare profile having moved into a C-class background range, basically. Over the past several hours, you're seeing an average of a C-class X-ray output without any significant flares, but this one was almost an M-class, so that was C8.1. Peak flux there around 11:15 this morning on the 15th. So no spikes in the proton flux. Don't be surprised to see some here. Coming up, if we get any relativistic particles from major flares. And here's the onset of a coronal hole wind stream. So you can see the solar wind density made it up to about 32 protons per cubic centimeter. And then dropped down to a more moderate level right as the solar wind speed came up. So it reached as high as about around 550 kilometers per second. Current conditions are about 520 kilometers per second for the solar wind speed. Solar wind density just over 10 protons per cubic centimeter. And that has caused an uptick in geomagnetism. And that's what you're looking at there. The KP index is a measurement of global geomagnetism. Here's Earth's magnetic moment from space over the last 4 hours. And again, that is caused by that onset of that high-speed coronal hole wind stream. A classic coronal hole wind stream signal here. And we're seeing fairly steady pressure here from Earth's geomagnetic moment from space. Again, that's 4 hours of data. Here are ground magnetic perturbations, and we're seeing significant ones here. There could be some aurorae visible as a result of this, likely are. This is geospace delta B, changes to Earth's B field at the surface level, Earth's magnetic moment from the ground level. And like the last pane, that is 4 hours of data, courtesy University of Michigan. Let's put that back to where it was as it refreshed. Next, we'll show you a solar system forecast. Here's where things are now. There's where things will be in a week. And we were only 10 days from Christmas, folks. It's the 15th of December. Have you checked out our links? They make great gifts. smAshoMash.com's merch shop, smAsho merch. Some poignant designs. Next, a star chart. You can see the ecliptic there, which is the yellow line. It's in-the-sky.org. The ecliptic showing Mars having risen ahead of the sun. And I've regained control of my browser. Yay! Don't you just love it when a web page takes control of your browser? It's fun stuff. Anyway, you can see Mars having risen ahead of the sun there. If you've got a clear view of the horizon, you may see Mars rising ahead of the sun. So next, we're going to show you the view from stereo A, the coronagraph out there, as well as Lagrange point 1, the location of the SOHO-LASCO C3. There was a minor coronal mass ejection here. You can see on stereo A a little bit of ejecta making its way out of the corona there. Otherwise, pretty calm. No coronal mass ejections. The likelihood of those remains very high. The coronal mass ejection watch remains in effect. We may have to upgrade that to a warning depending on what we see happening today. Keep in mind, solar flares are very spontaneous. And don't get solar flares and coronal mass ejections confused. Solar flares are X-ray photons. Coronal mass ejections are solar protons, gas blasting out of the solar corona. Did you check out our cosmology segment yesterday? It's quite good. And you can find our playlists at youtube.com/smashamash/playlists. Yesterday's was integrated into the daily space weather video. More on that in a minute. Next, the astronomy picture of the day featuring some satellites and Comet C2021A1 Leonard, which may be visible to the naked eye right now. I'm not really following. Too much stuff going on here at the Smash News Network, least busted name in news. This one from Orion Space's Yangwang 1 Space Telescope. You can see also the aurora there, an air glow, and a great view of Comet Leonard. Did you watch yesterday's video? I'll bet you didn't. The thumbnail says 666, the number of the... And if you're wondering what's the number of, you got to watch the video to find that out. Now, on the channel, we regularly talk about what's going on around the galactic core. The blue object there in the middle of this image is Sagittarius A star. That is the supermassive radio source and gravity source around which a lot of massive, bright blue stars are orbiting near the galactic core. And you can find a great article about this here on SciTech Daily, entitled Watch Stars Race Around the Milky Way Supermassive Black Hole at Mind-Boggling Speeds. We'll just call it a massive radio source. And you can find some great animations in here and a great zoom-in to the core of the Milky Way galaxy. Don't be frightened of Sagittarius A star. It's not going to kill you. And neither is the sun. We apologize if the space weather videos are not scary enough. We leveraged ourselves in the realm of space weather on purpose. I've been deep into studying space phenomenon since before kindergarten, frankly, as I wondered what was going on with cosmic rays in the early 1980s. Anyway, we're going to show you one zoom in here, just a spectacular zoom in with some more recent observations of some of these massive stars around the galactic core. Let's pick this one. And it's very interesting what's going on in the cores of galaxies, folks. We don't always have very good views of what's going on in the cores of galaxies, but through various different wavelengths, we can sort of figure out what's happening in there. And there are stars that are orbiting the galactic core at speeds approaching the solar wind speed. Hundreds of kilometers per second are the speeds of these stars. They are massive stars, and they tend to be so large that you would be inside them if they were located where the sun is located. And we're just zooming in, way in, and you'll be able to see an obvious point around which all of these stars are orbiting. So that point around which the stars are orbiting, that's the massive radio source known as Sagittarius A star. And let me just reiterate that it's not going to kill you. Here they zoom in even farther. And these images from just this year showing the incredible motion and the highly irregular orbits, the highly eccentric orbits of S55 and S29. Again, you can find that article at SciTech Daily. That's today's cosmology segment. If you didn't watch yesterday's daily space weather video, check that out. It's got 666, the number of the things. Let's look at charging hazards. We do see some charging hazards here. Moving into the western Pacific, some surface charging there north of the equator. So some chaos going on in the electron flux. There's the 1-year chart of the relativistic electrons. Here's a 3-day graph from the GO 16 and 17's measurements, using radiography to measure the electron content at the F ionosphere layer from their geosynchronous orbits. Here's a forecast model. I would tend to agree. We'll see slightly lower levels until this coronal hole wind stream subsides. Then we'll see a big uptick. Next, we're going to show you the total electron content forecast, which is basically this area from your GPS satellite down to your handset, showing you the most likely locations for GPS errors. And as we typically see on the channel, we're seeing chaos as a result of low electron flux, or at least associated with low electron flux, right? So these bands of electrons tend to be more organized when we're at more moderate to high levels of electron flux. And during coronal hole wind streams, we see the electron flux crater regularly. We've documented it for years on the channel. And you can see some mild GPS errors happening there. North America, northern Canada, some around the Southern Ocean and Antarctica as well. These usually, most GPS errors occur around the equator around noontime. That's when you want to have your Wi-Fi accuracy turned on. Next, we're going to show you the F ionosphere layer, located at about 300 kilometers of altitude. Here's the vibrational frequency ionogram in megahertz, millions of vibrations per second, going on above your head right now, folks. There's a lot of things shaking up there, and this is a measurement of that vibration. In many ways, the bridge between Earth and space. We're seeing continued anomalies here in places like the South Atlantic and South Pacific, around the Drake Passage, which we briefly talked about yesterday. One of the weirdest places in the world, folks, this area right here, where the Atlantic and Pacific Ocean are forced to reach static equilibrium. There's a lot of water sloshing back and forth through the Drake Passage, as the Atlantic and Pacific Oceans are kind of large bodies of water when you think of it. Anyway, we're seeing continued anomalies here. This is the anomalygram in megahertz from the 30-day median. And lots of anomalies there around the South Pacific, the Drake Passage, the Southern Ocean, Antarctica, etc. There's the latest image. That's 1300 Universal Time ionogram. And there's the anomalygram. Let's do bonus features. And the first bonus feature today is from Lermonth, Australia, the ground-based solar observatory there. And you can see how bright these active regions are over here. Quite significant. Quite likely to produce major flares. Also, coronal mass ejection watch still in effect. We do see some plasma filaments down here reorganizing themselves And there may be a coronal mass ejection happening as we speak, as we see a filament sort of looking like it vanishes there, an indication it could be headed our direction. So we may have to make another video about that, and you can see this plasma filament reorientation happening down here. That doesn't look like a coronal mass ejection. It looks like a collapse of a filament, but a large prominence certainly there. Great imagery there from the GOES 16 SUVI with its wider angle. And of course, as always, we'll show you the colorized magnetogram and latest intensitygram. So that's a beta gamma class sunspot, beta gamma class, beta gamma class, beta gamma class. That's also a sunspot up there. That looks like beta class as well. So yeah, the likelihood of solar flares way up. We're going to be at a sunspot number approaching 100 by the end of the day today. Quite complex magnetic fields, especially this one right here. But really all of those sunspots are capable of producing flares. And we'll have to save cosmic rays for a later video. Today we'll close out the video in 304 angstroms ionized helium. A lot of helium in those bright spots, and this is a heliogram, really. Where you see white, that means there's a lot of helium, and when you see black, that means there's no helium. It's a very specific portion of the ultraviolet light spectrum, the portion associated with hot ionized helium gas. Spectacular imagery there of the past 24 hours from the SDO. And we'll close things out with a full disc view. Thanks for tuning in, folks. Congratulations on realizing the channel exists. Please tell your friends and foes about us. Press share on Facebook, etc. We don't believe the algorithms are recommending us at all for some reason, despite the channel being monetized. So thanks again, viewers, and may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted. Name it news.